Welcome to a new episode of the MBSE-Podcast. Today, guess what? We have again a German as a guest. And I think we lost him. Now you're back, Sebastian.
You said the German word.
Yeah, I said the German word and okay, dropped out again. So it worked for the last half an hour, so I'm sure he'll be back in a second. Oh, I need a button for the Jeopardy music or something like that.
All right, good start.
Yeah, no
Yeah.
problem. Welcome back.
Okay. There we go.
So, what did I want to say? Oh, yeah, we have again a German guest. Yeah, and it's again absolute coincidence because Sebastian is living in the United States. And he is CEO of a very interesting startup for a new tool dealing with systems engineering and SysML v2 in some parts. And we will ask him a lot of questions. But before doing that, Sebastian, please introduce yourself.
Hi, nice to meet you. Again, I'm Sebastian, one of the co-founders of Dalus. I was born in Munich in Germany, but now, as Christian already mentioned, I'm living in San Francisco about half a year, so enjoying my life here. Even though it's actually like the weather is nicer in Germany than it is in San Francisco, so you probably have the warmer weather there. We started Dalus over a year ago with my co-founder Elliot, who studied aerospace engineering and has worked as a test and system engineer at kind of like a major aerospace defense company in the US. And I personally came more from like the startup world, and I had two companies before, and I knew kind of like how modern software could look like. And then when Elliot came to me and talked, hey, there might be a way to like build like a more modern model-based system engineering software, and there's this new thing, SysML v2 coming, which we already talked like about a year ago, then this was kind of like the introduction of how we started Dalus in 2024.
Okay, yeah, great. So also welcome from my side. It's great that you are here with us. And well, yeah, you have a company called Dalus, and the tool, it has the same name, if I understood this correctly.
Yeah, it's the same. Yeah.
Okay, okay. Yeah, so well, give us a brief overview of the tool. What kind of tool is it?
Right. So when we started with the company or with Dalus, the tool, we really said we don't want to boil the ocean. So we really want to focus just on the core parts that a system engineer would do. So what we don't do is, if you would handle with like project management or like supply chain or like your CAD files, like we truly focus on the core system engineering parts in our software, right? So when I say that, I mean requirements management, system architecture, verification, validation, both the structural and the behavioral decomposition of your system. We have ways to do analysis on our software. You can run your MATLAB or Python codes to actually especially perform. Okay, it seems like my camera is shutting off. I don't know why. Let me fix it. Sorry.
But we still can hear you.
First time I'm trying out the new camera, so that's never try out new things for the first time.
Yeah, but it worked like a charm for over half an hour.
We had this before. It worked for the pre-session, and when we went live, bang.
So I'm switching to my other camera now, which won't shut off. So this will be now.
Yeah.
Okay.
We will keep this now. Can you hear me?
Yes.
Yes, we can hear you.
Can you hear us? Is the question.
So we can hear you, Sebastian.
Okay, perfect. Yeah.
Okay.
Yeah, the problem was I tried a new camera, so now the quality is different, but this is my webcam. So again, what I was trying to say is like something I learned is never try out new tech for the first time if it's important.
No risk, no fun.
Now there won't be any problems because the other camera was just like shutting off all the time, I think because of the battery, but this one is connected. So no tech problems from now on. So yeah, I was kind of like finishing just saying what I guess the tools that we're offering. I think I was already finished.
Okay.
Okay. And what was the motivation for building that kind of tool and then starting a company in this field?
Right. Yeah. So it came from two sides. So again, my co-founder Elliot worked at Arid Rocketdyne before, which some may or may not know, working on kind of like, a lot of rocket engine stuff for more like the older generations, let's say. And they're kind of like a very like, let's say try to engage with like system engineering and model-based system engineering over the last decade. And my co-founder was just like experienced that in firsthand how the implementation of, without saying names, but like more like enterprise or like the legacy tools in the space were just like really complicated. And I think that there's like no surprise for a lot of people. And that was like over a year ago. So when he recognized that and he himself like was dealing with more like the legacy tool on a day-to-day basis of this organization, he really felt like this shouldn't be like how it should be done and like what the tuning should look like just in terms of collaboration. And at the end of the day, no one really was actually updating information in tools. So you need to pick up the phone and actually call the people to verify if the information is true, which usually was not. So that was always a big mistake. And funny enough, when Elliot was like talking to me and exploring the space together with me, I was in a project with the European Space Agency for like 3 months on a lunar greenhouse module. So we basically were using kind of like Cameo to design a system model of a lunar greenhouse module with like other system engineers at the European Space Agency. And something that was like obvious for me as well is just like, okay, I'm kind of like a newbie to the whole space. And I literally, after even 3 months, had like not a really great idea how to do anything in the software. So I really felt for if there's any organization that tries to adopt to the space of system engineering and tries it like a new tool, our core belief was it shouldn't take 6 months, let's say, for like tool training to get started with the tool. So one of our core theses as Dalus is really just we want to keep it simple, easy to use, while still maintaining kind of like more the enterprise kind of like functionality of the software, right? We don't want to be just like a requirements tracker or a visual diagram tool. Like, no, it should be a sophisticated model-based system engineering tool, like an engineering software, which is really hard to build, while still keeping the simplicity and easy to use so you can start within a few days. But I think that's what we try to accomplish from what our users are saying, I think already accomplished to some degree.
So nowadays, when you think of an MBSE modeling tool, well, SysML v2 quickly comes to mind, but at least it does for me, of course. And when I visit your website, Dalus.io, SysML v2 is not immediately apparent there. So, well, you find the term somewhere in your blog post. So it's not primarily a SysML v2 modeling tool, but it's still included. So how exactly does it all fit together?
Yeah. When we started, we saw that there's kind of like there are like two different people getting into system engineering or who want to do like model-based system engineering. The one who are aware of existing tools, existing standards, existing languages, and the others should say, usually like more like startups or like smaller to medium-sized companies who say, hey, we're building this complex thing. We actually just hired our first couple of system engineers and we don't really know anything, and we don't really have any really tools. We don't have any standards yet. We don't know anything. And we saw that there's like a big problem, because that kind of like a lot of companies are overwhelmed then if they start learning about it, if they start learning the tools, the standards, etc. And they actually, after a few months, say, oh, actually, this is way too much effort. This is way too much work. Let's go back to documents. So what we believed then was saying, we don't want to be like, it shouldn't look like let's say a hurdle to start doing system engineering and start building models and start actually incorporating that into your company. So a lot of the companies that use Dalus, like they don't come from a background where they are even aware of what SysML is or like all the standards are, but they rather just want to do system engineering. So because of that, we primarily want to say, hey, we focus on getting you on board of doing system engineering as fast as possible. But if you want, and we can talk about this in a second, and also at the end, I guess, when I show the software, show you how it looks, but you can export your whole model you create in Dalus as a SysML v2, either as a .sysml file or as SysML v2, just plain code. And we may add like functionality over time. We talked about this a bit earlier in terms of like maybe adding a sidebar where you can actually edit the SysML v2 as a text. But our core, what we believed in, the two biggest things that something like SysML enables is, first of all, everybody knows what you're talking about, right? If you have syntax and like everyone knows what a pour is, a like action is. If that is like across different organizations and you share models, like everybody is aware what certain things mean. So a lot of the syntax we are using even in the front end of our software. And then when you want to export the model again, you can export in SysML2 to share with others, so it can even open it in other tools. So that was the core thing. It's like we believe in the interoperability of different tools. If you have the same kind of like modeling language, and also like being aware of like different organizations, different teams, what certain terms and like words mean.
Okay, cool. And you are one of the few web-based and even cloud-native tools I know in the sphere of systems engineering, especially of model-based systems engineering. Is this also an advantage for your users? Or is it just not installing a software?
Right. Yeah, I mean, that was when we started out building a company, it was also like a big decision to make. Do we want to build, let's say, for example, build on top of Eclipse, or do we want to build on top of like existing like Java-based like frameworks, or do we really want to build everything from scratch? And building everything from scratch certainly means a way harder path, a way more complicated path. But I think we choose that direction because it enables us to be more like creative, and we can be more free in terms of like how we want to set up the software, how we want to like implement certain functionalities. If we truly just like build everything from scratch. So and we basically offer, even though that's more, I would say, if we actually start working with bigger enterprises on a more like, let's say, one-on-one basis, like we do have the capability to deploy on premise and like securely host it on the customer side, like without cloud-based and web-based access. But that's usually for the big enterprises, regulated data, your aerospace defense customers. But for the vast majority, web-based, cloud-based, autosave all the efforts you do in your model should be the standard, at least from, again, coming from a background, how modern software in general works, looks, feels. Is you don't need to like save your file, you don't need to, you can work collaboratively with multiple people in the same model while seeing like, oh, the other person is currently doing on this system, the other person is working on that, which is really hard to do if you like not cloud-based or web-based.
From my point of view, it's really very often underrated, the advantage that you have the server component automatically. So in former times you had some desktop application, and then you needed a server application on top. And if you didn't have it, you could work with file exchange, and exactly what you said in the last seconds or minutes is a big advantage, and hopefully people will get this more and more.
It's also about scalability, right? Like the bigger your
Sure.
model gets, the more things you have in your model. With cloud-based, there's like no limitations. You can have like tens of thousands of components and systems, and the model, because if you load a model, or like in general, if you load data in a cloud-based environment, it doesn't load everything at once. It loads it in chunks, right? Compared to if you load it locally. So if you try to spin up a locally hosted model, it can take 5-10 minutes sometimes if it's big. And in a cloud-based environment, the way it works is just like chunk-based, right? So if you just look on a certain subsystem, it just loads that and not the rest. So that's why it's so performant. Even though it gets bigger and bigger over time, you don't really lose any performance. And the same goes with the kind of like the AI. Like if you want to enable kind of like AI within your software in general, like there's kind of like, you can talk about computation costs, and it gets harder and more expensive if you try to do that on like a local basis compared to cloud.
Well, more and more system tools, there are more players on the market now. They also provide web-based modeling tools. So you run it's in a browser, so it's a cloud tool then. And then the question comes up, what about when I'm offline? So I'm in the intercontinental flight and would like to work on the models, then I'm offline, things like that. Is this possible with your tool, or do you hear that it's an issue? Maybe it isn't an issue because everyone is always online.
It's technically possible. We don't have it right now. We talked about it like once or twice internally. It didn't came as a request from any company right now that uses us, so we didn't put it on the front of our kind of like feature list, but it's certainly possible. I would imagine we would have it maybe in a few months or half a year, but it's certainly possible.
Okay.
Kind of like an offline mode.
Yeah, I think that's actually, it's not a real issue, no? Because in most cases you are online, or
Yeah, mostly online.
Yeah. You also mentioned AI. That's another big topic these days. A few weeks ago, someone mentioned that's the most underhyped topic in engineering because nobody really is aware of what are really the opportunities with AI. So AI is integrated in Dallas. How does it work? Is it ChatGPT in there or something else?
Yeah. AI is certainly not the most underrated here in San Francisco.
Okay.
I think from the
it was a European
around us. Yeah. I think it's interesting, especially talking about like AI and engineering, because it's very, very different if you to decide what should it do or what shouldn't. It's just like we don't know it at all. Like we just, the way we view AI and like ourselves is just we experiment a lot of it. We try to enable it a lot and then just see how our users use it and see what they like or what they don't like. So and I can show this at the end in a demo as well. But there are certain ways how we use AI in like certain parts of the software, and it's not just like a chatbot that spins up OpenAI's like ChatGPT and you can ask it questions. It's more like it has server, like if some of the listeners know about like what AI agents are, it's kind of like different AIs have different like personalities or have different tasks with our software to do certain things. So for example, there's one way where, and that's usually good for if you just really want to have a big chunk of projects in your organization going from document-based to like model-based, which is like one of the use cases one of our customers had. We're like, oh, we have like actually dozens of projects that are still document-based. We want to be model-based, but we don't have the people internally to do so. So something we enable to do is just saying, okay, we upload, let's say, pages of PDF, design specification documents, whatever, just where requirements or whatever system information is defined in PDFs. We extract the requirements automatically, put them in our requirements management table. And then in the next step, kind of like create the system architecture and the system model based on the PDF and the existing requirements, and then trace the requirements back to the powers of subsystems in the model. And with that, you can kind of like go at least to some, like not 100%, but like 70% of your requirements and system architecture is finished from like just done by AI in like 5 minutes. And I think something that enables is just also like fast prototyping, fast, just like the very early conceptual design phase of like of building your model. And so that's one big part, is kind of like just extracting requirements. And then the whole kind of like, we call it AI Copilot, or whatever, Dalus and like whatever you want it, but you have like a right sidebar where you can just like chat with it, but it doesn't only give you, so it's first of all, it's trained a lot of like publicly available best practices on system engineering, right? So it has, I would assume, or like I have a very high, let's say, standard of like quality. So it's just like dozens of like very like, let's say, it has several iterations of trainings, and we kind of like traced or like tested this with like system engineering experts to kind of like verify, oh, is this output the AI gives better or worse than what you would ask it if you go to ChatGPT, for example? And it's usually like better. So just asking it and like helping it is one thing, but it can actually also like make changes in your model. So if you tell it to add a certain subsystem with parts, it will do this. If you tell it to add these 5 ports to that thing, it will do it. Like it would go in your architecture and it will actually add these things, which is like very different than just like chat-based and like ask-based. And it can find design flaws in your system. Like you can ask it, hey, does my model look correct? And it tells you, oh, there are like 3 port names missing here. There's like 2 connections that are wrong here. This interface from this to this direction is the wrong direction. And this just enables way more possibilities. It also has ways that, I think it's funny because like I was on a call like a few days ago and someone asked me if, can you also create BOM lists, like those of material lists within the software? And I was like, no, we don't have this. But then I was like, oh, let's just ask AI. And like, because it was an existing model, whatever. And obviously that was like very sophisticated to just like create this BOM list based on existing system models. So there we have like a BOM list feature, right? Just so it really gives like ways that I don't even know what it can be used for. So we just like experiment a lot with it and see what the people use it for. Yeah.
But that's interesting. You mentioned already requirements and now BOMs. How do you integrate in existing tool chains like requirements management tools, simulation tools, or even PLM tools who are managing BOMs typically?
Good question. Yeah, there's hundreds of integrations we could possibly build. And I think we'll build. It's just a matter of time and effort, honestly. I can say that a very big integration we are kind of like working on is with Polarion right now, because that's kind of like one of the integrations that's needed by one of our customers. That's usually how we generally think about integrations. Is we don't want to build integrations like just for the fun of building integrations. It usually comes from, we have an existing customer, an existing company using us. They use us and they use our software and they need this. And then we're like, okay, let's do it. And Polarion is like one of the first ones. We do have a GitLab integration that's already in the software for like storing code, which is like another maybe different way of like something you can do in our software is like you can actually run your analysis. We have an in-browser code editor to also, with the help of AI, write you analysis scripts and analysis from like Python and MATLAB to actually run kind of like more the behavior and the function of the system. And we plot you kind of like graphs and the outputs of the system level simulations in the software, which is like more on, again, functional like behavioral modeling side. But you can store all of the kind of like the code snippets and your analysis in GitLab and kind of like have live kind of like traceability between that as well. But yeah, there's so much more we need to build. All the integrations with the JAMAs and the doors and the existing, even like we don't want to be, again, like we try to have as many integrations as possible, and integrate with CAD software, integrate with this. It's just a matter of time, and we don't want to do like integrations that no one needs. So just time.
Mm-hmm. And do you have an API? So that's the other direction. So you have not to write the integration. The other tool can integrate you. So if you provide the information through an API.
We have an open API. Yeah, it's if you go to docs.dalus.io is where we have our documentation of our software in general, but it's also where we store our public API.
Okay, cool. So your tool is brand new. So what's the roadmap for Dalus? So what are there any big features already planned for the next editions?
A lot of the work going on right now here is just making the tool kind of like really stable and enterprise ready. Like I think when you're starting out building like a company or like a tool, it's in the beginning a lot about features and like front end and like this is how it looks, this is what it can do. But now after some time you came across, hey, how can I as a team manager, how can I store the information of my members and see their data and manage their subscriptions, whatever. These are things that you don't even think about in the beginning, but it takes a lot of like infrastructure work you need to do. So a lot of the even like safety stuff and like how do you make it so the software is like aligned with the whatever standards the customers use you are, and like all of that work that you don't even think about in the beginning is now kind of like coming up if you do actual customer work, which is great. But that means you slow down, and like in the beginning we put like a feature every week and it was great. And we still, I would say, are in a very like we try to publish new things and like basically have like feature releases every other week with like new big feature releases. The next one that's upcoming for us is kind of like version control. So being able to version control your whole model in a Git-like style, so you can kind of like branch off your system model so other people can make changes and you can like merge it back, and you actually have like a visual interface where you would see this node was moved from here to here, and you as a owner, system engineering manager, you would need to decide which version you want to kind of like have as the main, as the truth. So this is something we're working on for a while now, which is like a big thing. Once we publish that, so that will probably be the next big feature we're gonna relaunch, and a lot of other things that I'm not being able to talk right now, but like it's a fun journey. But yeah, a lot of the stuff right now is really just like making it robust, making it just like if you're building, I think engineering software in general is like very different to a lot of the other more like software, especially when it comes to like, oh, like it can't make a mistake here and there. Like that can't happen. A bug in a engineering software is way different than a bug in a, I don't know, a tool that helps you write copywriting code with AI. I don't know. Like it's way more like it needs to be just like robust and no problem should occur. So that's just like a lot of the work right now is just doing that.
Cool. All right, so we are talking already for 30 minutes. Maybe we want to switch to the demo part. So to all our audio-only listeners, this is the point in time where you might switch to YouTube and watch the demo of Sebastian, and I will add a bookmark in the timeline so you can jump right to the demo in the YouTube video afterwards.
Cool. Should I just share my screen? Does it work?
Yes. Yeah.
Cool. All right. Still screen?
Yes, it's there.
Cool. All right. I want to do two quick demos. I want to show kind of like with an existing kind of like an existing model that's already created, kind of like some of the core functionalities, and then like a quick second demo where I go into more the AI features and like starting from scratch, and what if we actually start from zero using the AI to do some things, because I think that's a nice thing to differentiate. So starting with the existing model, we have like a prototype demo of like a rocket here, obviously super simplified for demo purposes. But the first thing you kind of like see here is just like we start out with like the structural decomposition, like the system architecture is where we currently are. So if you look here over pages, we're in the architecture view. And this is very kind of like as easy to use as you have your like part elements, and you can like drag and drop them here to the system and connect them with like other parts, and you automatically have like 2 ports create an interface, and you can add multiple more ports if you want to the parts, and add more interfaces to these connections. And we automatically kind of like track these in terms of like decomposition with like subsystems and parts. So in our software, everything is kind of like the core part element. So if you look at this example, the rocket engine, you would see that it has like 16 sub elements. So if I double click into that, I would see, and you can see this over here at the top left, you could see that I go like 1 level deeper. It's like similar to like a Simulink behavior, where I would now see all the subsystem or the parts of the rocket engine. And in theory, I could do this like over and over again. And in the back, we just track that, oh, like this is like decomposed of like certain parts and subsystems. And within the structural decomposition, if you click on a node, you would always have like, if you look at the right sidebar, this is kind of like the properties of the part, right? So you have certain attributes that you can assign to it, where we have like a library of, so you can give it a name, and we have like a library of like unit types you can look for. So if you want to have like kilogram, you just say gram, prefix kilo, and then you have, let's say 100 kilogram. And oops, and this is how I added like the 100 kilogram attribute, which will kind of like be storing and will be important later on for actually verifying functional requirements. But you can see that there's already some existing attributes for this rocket engine, which will be important for a second, especially this one, the firing duration, which is currently at 300 seconds. And then you could see all the part properties like ports and subparts, actions, states. Also for the interfaces, you would basically have an existing, you can either create your own, or again, what we offer is kind of like just a library of, for example, if it's like matter, there's certain like fluids and gases we support out of the box, or if it's certain like data protocols that you can just select from, or again, you can also just like kind of like have your own and bring your own into the software. And then if you're in the root level view, you can also switch here from our part view to the function view. And this is where you would start modeling kind of like more like the functional decomposition of the system. So in this case, I have my root level function as like develop payload, which then is in like sub-functions like generate thrust, maintain structure integrity. And you could do this like over and over in like different sub-functions of sub-functions. So this is kind of like where the function decomposition is happening. And then if you go deeper into like a subsystem, you'll actually be able to switch from, again, the part view to a state view and an action view. So the state view of a system, so again, we are in the rocket engine. So the state view would be just like a state machine diagram. So you can bring in different states and define transitions. And the action view is where you'll be able to manage, actually, this is where kind of like the behavior of the system comes in the modeling. So this is where we have these like action nodes, where you can actually run your code, where you can bring in your analysis code and run your analysis in the software. And to show an example of how this might work, we can switch now from our architecture to our requirements view. And this is where you'd manage your requirements, your sub-requirements. You could define a requirement type, name, statement. You can also add your own columns, whatever you want to customize it to, and then kind of like assign it to whatever parts or subsystem within the system architecture that should be assigned to. You can do this from here, or within the architecture, you also have these like small like buttons where you can see which requirement is assigned to this part, or you can assign a new one. And I wanna showcase a very specific example. And this is, if you look at this requirement here, the firing duration requirement, we basically say that the firing duration of the rocket engine should be minimum 300 seconds.
And if we look at the, let's see, if we look at the status, I can click here and I can actually give this a constraint. So I have this checkbox here on my requirement, but which basically says auto update based on constraints. And if I have this selected, this number of my function requirement will actually adjust or change based on analysis I run for this requirement. So to showcase this, again, the Rocket Engine filing duration currently is complete because it's within the set constraints. If I would change to our architecture, I'm from a main view, go to my Rocket Engine, go to our action view. This is where we actually see that the filing duration is as an output defined. So the way this works is, again, I just have my analysis here that runs certain Python scripts from here to here to here. And I can kind of like click on run, and that kind of like runs the analysis. So that first starts the propeller flow, then to the combustion, and then to the thrust. This is how we get the 300 seconds as a filing duration here right now. So what I could do now, I can actually change certain input parameters here at the beginning and say, what if instead of 0.1 kilogram as my fuel rate, I have 0.2, and I run the analysis again, which has an impact on thrust, which is now actually, if you see here, the filing duration is now failed because it's now 240 seconds, which if we go back is now actually it auto updated from complete to failed because it's now outside of the constraints that I've set. So through that, we actually see now, okay, the requirement is not failing, so we need to make changes again. And again, in this case, I know what the number needs to be. And you don't need to do all of this, but this is just for more like advanced use cases. If you actually want to bring in your analysis to the software and actually want to perform a requirements verification within your software. But now I changed it back, and now the requirement is now complete. We can also handle kind of like if we look at the, let's see, if we look at this, let's see, I think it should be, yeah. So you can see that if you look at the code, for example, we get certain input parameters from like the attributes. Like when we assign attributes to a part, we can actually get these here within the code to work with them, perform certain calculations, and can do the analysis. So then we can also actually see that we can visualize the outputs here, in this case, propellant mass over time as a graph or as a table. So this can also be verified. So all of that is kind of like a workflow from going from requirements verification for like functional requirement to the system architecture. There are some small parts, like we're also able to handle like any types of like documents. So if you have any types of like design files, or let's say you have PDFs or Excels, whatever, you can assign these to parts as well if you want. So you can assign these to like a part node and kind of like trace that back if needed. A big thing that was really important for us to build within the software is kind of like the collaboration functionality. So when you're working within a system model, you can just like share the system model with your colleagues. So you can enter the email, give them certain edit permission. And then if I would, let's see, it should work like this when I and I'm just trying to replicate if there would be multiple users in the same model. But you can see that in real time, you can see kind of like the other person's cursor. You can see in real time what the person is currently doing in the system model.
Cool.
And in real time, you could see the changes that are being made. So that's an important thing. As well as, if needed, you can actually access a public view only link to the model, which is from my what I've heard especially interesting for like educators. So if you click on the share button, it usually creates like a link that you can share with others, and they don't need to make an account to kind of like view the model. And in terms of export, I think this is again interesting now to some of the listeners. There are two ways of exporting the model. If you don't like SysML and SysML 2, you can also export it as just like plain, like an HTML that looks like this. So it just exports like a plain HTML of like the requirements table and kind of like the states, the actions, the interfaces. It's like a very like, if you're not familiar, if you need to send it to someone as a text file and they just need to look at the output, you can do it like this. But again, which is maybe more interesting, you can also click here on the export SysML v2. And as I mentioned earlier, you can export it as a .sysml file or as an HTML preview. And if you click on HTML preview, it gives you just like the output and sees all the SysML v2 code for the current model. Which I think I posted like a demo on my LinkedIn where I also showcase verifying the exported code in the SysML v2 lab for like verifying that it actually works and like visualizing it.
Cool.
So there are no syntax errors. So this is kind of like the first part of the demo. Now what I want to do is actually want to showcase the AI. And for that, I'm going to go into like an empty model. And I'm going to take a satellite as an example. So we go into this empty model. So nothing in the architecture, nothing in the requirements. And we start out by importing a PDF into the requirements table to extract. So what I'm going to do here is I go to this CubeSat design specification document. I think it's like 70 pages or something like that. It just has a bunch of like requirements for the CubeSat and some information. So I upload that and we use a multi-model LLM, AI, which basically means that the AI we use doesn't only look at the text, but it also understands any type of image or graph or anything that's existing in the whole PDF to extract the requirements. So even if there are requirements in like non-text form, we can also extract them. So that should be finished. Usually it takes less than a minute, like 20, 30 seconds to process, since it kind of like it maps it. So again, it puts it into like this format where it like defines the requirement type. It creates a name for the requirement if it extracted from that. And then the statement is more or less just like a copy paste usually. So it finished now. We have 46 requirements, extract them from the PDF. And yeah, you can also double check that if there's this info button here where it actually shows the reference. So it says this requirement was extracted from this file from page 9 in this text. So you can actually verify that this requirement is not like was hallucinated as an extraction, but it actually was like from this side, from this part. And you can double check back with that. So now we have all the requirements and we go to our architecture. And now we have the switch where you can switch to our Copilot here. And this is where kind of like you can chat with our whole kind of like model in the system. Or again, what I'm going to do now is I'm going to tell it to create a model based on my existing requirements. So create a system model of a CubeSat based on my existing requirements. And again, the way the AI works here is that first it kind of like looks at kind of like the storage of the model, like, hey, is there anything already there? Is there anything I can already look at that I can use for my answer that I can use? And then it kind of like thinks. So something interesting that we implemented is that you will see in a second is that you can actually see the AI thoughts. So whatever the AI thinks in terms of steps, it actually showcases it here. So now it says I'm going to create a comprehensive CubeSat model based on these requirements. I can already see requirements covering structural design, power systems, communication, safety, thermal management. Let me create a hierarchical system model that addresses these requirements. And the way we trained the AI to work is basically, again, that's why it's better than using anything out of the box from any kind of like existing AI model, is we kind of like train it to think like a system engineer. So it would start by the core part, then subsysting, decomposing, which you would usually need to like write long prompts for if you go to like any of the, the OpenAIs or the Claudes or whatever. And we also gave it has a ton of information as context on best practices on system engineering. So everything from the NASA System Engineering Handbook to INCOSE standards to this and this and this, it has it in its brain, so to say. So it can reference certain things whenever needed. So looking back to our output now from the AI, we can see that it added 77 parts now to the core structure of the system. So the way this works is basically it first would tell you what it would change. So green means like it would add it. If it would be orange, it would mean it would change something in the system model. And red means that it would delete something. In this case, it adds 77 parts. It doesn't change anything. It doesn't delete anything. And you can already see these are some of the parts it would add, some of the ports, and some of the interface connections. And it currently finished its sentence. So let's finish it for a second. But it also gives you a summary at the end. So here it says, I successfully created a CubeSat model. The model includes a system architecture, key features with the key subsystems, create the core requirements, again, trace it back. So what I can do now is I can actually click on these chunks of outputs. And again, right now there's nothing in here. So all I need to do is click on apply. And now you can already see in the left sidebar, it added all the things to the model. And I can now go ahead and create my CubeSat system. I go in it. Now it looks chunky. That's why we have kind of like an auto layout function here at the end. There's still some like overlaps. You need to like wrangle around a bit with the ports and interface. But yeah, it creates the core subsystems. And then even further.
Cool.
So if I click on my structure subsystem, it has some things added here. If I click on my altitude control system, it added things here as well. And the way I would like, I always try to tell people to use the AI is also in a very like, don't expect to do like one prompt and have like a perfect finished model after that. So like the way it should work is just like try to do it in steps, right? Hey, let's do the core subsystems first. After this, do in this one subsystem the core parts, right? And like do it step by step until you have the model to the stage you want to have it in. And you can again go ahead and also do your states, your function decomposition, your parts. Again, every single entity in the whole system model can be changed or can be updated with the AI in different languages. Something I learned yesterday. You can also use it in German and prompt it in German. It will give you German output. So it's
cool.
language agnostic. Is something I learned yesterday. But yeah, you can again you can use this however you want. But this was a quick demonstration going from there was nothing from a PDF to requirements, from requirements to a system model, and from now on you can go ahead and continue. But this was just a quick demonstration of the AI.
Okay. Maybe one quick question: does it also work the other direction with the AI? So you already have an existing model, and then ask the AI, is there something suspicious in the model? But
yeah, let's actually, because this is like a big like. Yeah, we just created it, but let's go to the more comprehensive like rocket model. And we can ask it, let's say,
like a, I don't know,
try.
an impact analysis. Now, what happens if I change this port or so? What's the impact?
Yeah. So I'm gonna first ask this, and then based on potential issues it will find, you can then I would like ask a follow-up question maybe in terms of like, hey, what if like this would change? Or what if like, you know,
Okay.
we would change this and that? It's interesting. Again, there's so many things I'm not even aware of that like sometimes users come to me and say, oh, this is cool that you could do this. And I was like, I'm learning that it can do this. So again, like you can perform pretty comprehensive, like again, if like working with all the attributes from all the parts, you can actually run like basic simulations with the AI and say, oh, like what if in this scenario you would change the attributes of this part to this, how would it impact the system? Like the AI is just really, really good at getting these kind of like connections made. So let's say what we get out of here. Oh, perfect. Yeah, that's like a good example of like why it says like experience technical issues, and it kind of like just tells you, like it tries to put off the work of the AI to you again and says this is what you should do.
Okay. That's it. I already wondered because the list of questions you
AI
can
is
ask.
waking up. Yeah.
Okay.
Yeah, that you always need to be nice to the AI. You always need to say thank you and good job, because at the end of the day, if the AI will like overrule us all, it will try to fight back. Yeah, I don't know what's currently wrong with this. I think because I'm still in the same system model. But yeah, let me try a different thing. Also, I want to do like a completely new system. That was something I had in mind. Someone of you can tell me, that's like always like a thing I always love to do. Like, tell me a system that you want to create with the AI. Like, you have full flexibility of whatever you want to choose. And I'm gonna prompt it, so no PDF, whatever. So it will be medium output, but give me any system you want.
So I work a lot with a delivery drone system. So a drone that can
Okay.
deliver goods also to ships that anchor in the harbor.
Okay. Let's be more specific. Want me as this model of a delivery drone system that, what did you mention? Or
That delivers goods to ships anchoring in the harbor or in a bay or to ships. It's not important if they anchor. Yeah.
okay.
Mhm.
Okay. The reason why I was trying to specify a bit because it can actually then come up with like also like the function decomposition and like not only the structure. But yeah, let's see what will come out. Yeah.
And now it will ask how far is the ship away. So anchoring would have been an interesting constraint.
True.
Yeah.
That's honestly something I was thinking about. Like there's a good like sometimes if you ask like follow-up questions first before actually giving an answer might help getting the output even better, right? So instead of giving an answer now, I would first ask you one or two follow-up questions in terms of like, you know, hey, just to clarify, how far is the ship away, right? Because that would make an impact on or like a change on the output. But yeah, as you can see, it kind of like just works. It works its way through. It's usually, again, it starts with the kind of like more like the system structure, then adds interfaces, and then goes all more to the behavior, so the states and transitions. And we can already kind of like add this like now, but I usually try to wait at the end of the output. But yeah, I think in general it's just like we see these AI, like if you'd ask me like, hey, what should the AI do and what shouldn't, like again, I don't have a strong opinion on this one. I just feel like all of this feels very experimental to some degree, and like people should use it like with caution and like, hey, like don't think like you don't need to do any modeling work after using the AI.
Yeah.
But at the same time, it's also like, if it's getting better and better and better over the months,
Mhm.
like, I think it's an important question to ask. If I'm a system engineer, what are the things in my day-to-day job that, like, where the AI might be better to do than I am right now? And
Mhm.
what are the things that I, as a person, will still be able to do better than anything else?
Yeah.
But if we look at the output again, let's actually add all of this to the system model. So we have the core delivery drone system, define some subsystems, then it added more subsystems. Then we have some ports. Then we add the interfaces. Again, need to work around here a bit. We have the states that we could switch to here. So it created the states, including the transition phases.
Mhm.
We have some requirements that are now added to the model. And like, there's also like a big like thing always, like, should requirements be AI generated or not? Again, my belief with this is like, you can just probably like it should help you, but like you should still come up with the requirements yourself. Again, this should be more like a look through these and like be the decision maker to say yes or no. Like, don't just keep them and like, oh yeah, the AI did it, like, let's continue. But yeah, so yeah, again, this is like
Cool.
again, what I always say, like it did some core decomposition of the system. Let's see, we have a cargo package navigation infrastructure. We have the target ship, which is connected to the navigation infrastructure. We have the communication. We have the core delivery drone system. So this is more like the general, like the zero level. If we go deeper into the delivery drone, this is where we have the decomposition of the navigation system, flight control system, power system, communication system. So and also, by the way, in terms of like usage, like the reason why these ports are like floating around here is because these are like connections from external, right? So and whenever there's like a, the reason these ports are there is because these are the, the incoming ports coming into the delivery drone, like the navigation data port or the communication port, and they go into the delivery port, and now you need to like manage them to kind of like
Where does it go?
connect them here within the defining. Correct. But yeah, you can now go ahead and say, okay, let's now add the core parts to the landing system. I need to say system. And then it again, the bigger the model gets, that's something that's true. Like the bigger the model gets, it usually gets slower because it needs to look through more data, right?
Yeah.
So if you have a model with tens of thousands of parts, they will take some time to make changes. But again, this is something that will like improve over time. But my follow-up prompt here, yeah.
That's an interesting use case now to change an existing model. Now it's not easy, but it's already impressive that an AI can generate a model from scratch, but to apply changes to an existing model, I think that's very
Even
nice.
next
And
level.
a more realistic use case, no? Typically there is
right.
something there.
Yeah.
Cool.
So in this case, it looked at, again, the whole system model, it identified the landing system, in this case subsystem, and now added these core parts like the landing gear, landing computer, stabilization system, landing lights, and again now creates the ports and interfaces to connect all the parts within the landing system. And these should be, these should be here now. So you can, let's add the ports and let's add the parts interfaces. And now you have again a ports interfaces for your landing system that we just did in a minute.
Oh,
And
cool.
yeah,
That was very
again,
cool.
this is how you can even make changes throughout the model and make changes. Yeah.
Okay. Cool. Very exciting. Thank you very much for that. Well,
Sure.
unfortunately, we are out of time for today. There are many more exciting topics to discuss. And well, I have lots of more questions, but well, we have not enough time. So maybe we should do another podcast on Dalus in the future. Yeah, thank you very much, Sebastian, for being here and giving us some insights in your tool. Very cool. And yeah, our next session for July hasn't been finalized yet. We try to do an episode in July, but it's also vacation time. But yeah, stay tuned. We will announce an episode as soon as we know the topic and the guest. We already have some ideas, but it's not scheduled yet. And well, with that, all that's left to say is do not forget.
Trust us. We are systems engineers.
Yes.
Goodbye.
And
Bye-bye.
goodbye.